engineering and how all of us, thank you, Udita or Charlotte. Of course, I forgot that again. So today's going to be more of a informal discussion or formal discussion on, bridging the gaps between the two disciplines, how we can, we being permafrost science and engineers, work together and kind of work towards a future where permafrost scientists and engineers are working together very closely. So we are doing a meeting style today, so that way if you have any questions, you can unmute yourself, you can pose the question, and then we'll have a bit of a discussion on it. So if you're uncomfortable and you'd rather just ask a question, you can feel free to type it in the chat and I can read it out to the panelists and we can go that route. So we have 3 of our panelists. We are potentially waiting for Dr. Chris Byrne to join. But for now, we'll get started and I will have all 3 of the panelists start to introduce yourself. If you can just keep yourself muted unless you're planning to ask a question, that would be appreciated. And yeah, so we'll get going. So maybe I'll start with you, Dr. Ruy, if you want to give a quick introduction to yourself, and then we'll move on to Dr. Dumais and then Dr. Doré.
Great, thank you. And thanks to PYRN and all the organizers that made this possible. I was unable to present my presentation in person. I did the Permafrost Science 1, but I have watched everyone else's since then, and it's been really great. It's a super nice opportunity to kind of meld these very similar disciplines. So as Adam said, my name is Dr. Ashley Ruy. I'm a permafrost geohazard scientist at the Northwest Territories Geological Survey in Yellowknife. So that's where I am right now. Prior to that, I did a PhD at Queen's University in permafrost science, and my specialty has been more so doing landscape scale, kind of susceptibility modeling of permafrost hazards. So my position here at the Territory is great, and the NWT is a really interesting location to work just because there's a really wide breadth of ground ice and different permafrost zones. So it's a really unique place to work and has really direct applications to cold regions engineering, as a lot of infrastructure is built on really sensitive permafrost. So it's been a really interesting place to kind of see how permafrost science and engineering really work closely. So I'll leave it at that for now and go to the next one. If anyone has questions, let me know.
All right, so I guess I'll introduce myself. I'm joining Ashley and thanking the PYRN for organizing the panel and the short course. They were all very good and very instructive for, I'm assuming, for everyone, including me. I am an assistant professor in civil engineering at the Royal Military College of Canada. And so I think of myself as a geotechnical engineer, so a civil engineer, and permafrost is a part of what I do, but I'm also specializing in transportation infrastructure and geotechnical engineering in general. And so I did my PhD and my master's as well as my bachelor degree at Laval University in Quebec City, and where there's a lot of permafrost work in engineering being done. And so it was a great place to be. And yeah, I guess that's it.
Okay, my name is Guillaume Lapointe. I'm a former professor at Laval University. Currently, my title is associate professor. So I retired 1 year ago now. So I have 35 years of experience with permafrost engineering, and mostly or essentially applied to transportation infrastructure, but also to other type of structure, but mostly on transportation infrastructure. So again, I've been doing research and teaching in cold region and permafrost engineering for actually the teaching part was the last 23 years. I initially was an engineer with the Quebec Ministry of Transportation, where I started working on some of the permafrost related problems in northern Quebec. So.
Awesome. Well, thank you three for the introduction. So to get us started off, I think we've listed a few questions and we posted on our. So we started with a few questions we posted on our PYRN Twitter page last night, and we got a few questions, and the executive committee has thought of a few questions as well. Oh, actually, Dr. Chris Byrne has just joined us, so I will. Hello. Hello, Dr. Byrne. How are you?
Fine.
Good. So we're just getting started here, and we just went around with quick rounds of introductions. So I was wondering if maybe you want to spend a minute or so introducing yourself before we get started with the first questions.
Yes, first of all, I apologize greatly for not coming at the very beginning. I was talking to two of my graduate students who are preparing their talk for the RCOP conference. Now, I would like to say that my name is Chris Byrne, and it's a delightful experience for me to be on this panel, because for some years now I've been working with Guy Doré in presentations of similar nature in terms of short courses at Inuvik and in Whitehorse. So it's very, very enjoyable for me to be here, and I will defer to everything that Guy says because he knows far more about permafrost engineering than I ever will do. I'm also extremely grateful to be on the platform with Ashley Ruy, because she's part of this fantastic new team of scientists working in the Northwest Territories in Yellowknife through the NTGS. And this will be, I think, for me and for many others, a very exciting group to watch for the first time, really a significant capacity in permafrost research in Northern Canada. And then finally, I'm also very, very happy to be on the platform with Simon Dumais, because Simon is one of our most exciting up-and-coming engineers in Northern Canada, in permafrost research in Canada. And it is a great honor to be here with the future of permafrost engineering research in Canada before our very eyes. As you know, I've spent quite a number of years working in permafrost field activities in Northwest Canada, and I'm in awe of the amount of interest that you have pulled together, Adam, and the other members of the PYRN committee have pulled together for this, for this series of webinars.
Thank you, Chris. Yeah, the pleasure is ours to be able to learn from all of you today. We're very excited to hear about permafrost science and engineering and the future of it in Canada, but also in other permafrost regions as well. So I'll pose the first question, and then I'll kind of give everyone a chance, or all four of you a chance, to comment on it and give us your thoughts. And then, because we're doing a meeting style today, we would love to hear from all of you in the audience. If you have any follow-up questions, please feel free to unmute yourself and jump in. That's the purpose of today. So one of the first questions, and I think Kumari might have brought this up last week, and Kumari, please, I told you last week that we could follow up with your question today, so please feel free to pose it after. But the first discussion point I wanted to ask is if there's already very strong working relationships between cold regions engineers and permafrost scientists, or if this is something where we need to put more focus and emphasis on in the future. So I don't know who wants to take a stab at that first. Just feel free to unmute yourself and provide us with your thoughts.
I'll just quickly jump in here. I think when Chris introduced himself, he provided a pretty good, great example of a strong working relationship between himself and Guy with respect to permafrost science and permafrost science engineering. And being a bit earlier in my career, seeing those types of relationships and the really great work that comes out of those, such as these short courses that have been done in Inuvik and Whitehorse, where you bring together permafrost science students and cold region engineers, is a really great opportunity to build those relationships. And I think that's kind of where it starts. And so more relationships, because these courses have been going on, I see being built. And I have a lot more colleagues that are engineers that I would have had probably before I started getting into short courses and joining some of these different working groups, such as Canadian Permafrost Association. So I think there are strong relationships, and I see a lot more strong relationships coming with this kind of snowballing effect coming out of these great relationships already.
Yeah, I think, Adam, the main point here is to ask yourself, what is your community? What is the community that you work with and who you work with? And in the case of permafrost activities in Canada, and now this is very Canadian perspective, and maybe Alaska and possibly Russia as well, the vast majority of the people who work in permafrost work in application of ideas in the permafrost environment. So the vast majority of people who are working in permafrost in Canada are actually working from an engineering perspective. They may be working for consulting organizations, or they may be working for a government. There are relatively few scientists who are working for government or for university in comparison with the number of people who work in practice. So that's the first point. It's not the case in Europe that that's true, because in Europe, in Switzerland, there are some engineers who work, of course, in the permafrost environment. But, you know, for example, the permafrost scientists who are based in Belgium don't have very much connection with permafrost engineering in Belgium, because there's no permafrost in Belgium. So that means that the nature of the community changes. And so it's really, a lot of it is to do with where you are located. And where you're located with people who share, who are living there and working there. And we are very fortunate in Canada to have a lot of permafrost, and therefore a lot of interest in permafrost. And the engineering side is where the applied interest is demonstrated and the capacity is fulfilled.
Maybe
Go ahead, Ashley.
I was just going to follow up with that comment from Chris and the fact, I guess, permafrost scientists working in government. So I've only been working with the governor of the Northwest Territories for 2.5 years, but it definitely has been a bit of an interesting experience in the sense that we get requests or questions from other departments in the territory about permafrost and how it's impacting, for example, the DEM store or the ITH. And so it's a interesting kind of avenue where, yeah, the work that we're doing has direct applications and vice versa. So it's kind of it's very different than academia, when I was in grad school, and from other academic colleagues who are definitely still in that research realm. So it's that combination between science and applied, which I think is really interesting, and I enjoy actually working for the government.
Well, maybe I could add a few words about the better cooperation between the science and engineers. And there's, of course, there's not only one group of engineer and one group of scientists. Of course, the scientists that work in academia don't have the same interest and the same mandate than scientists working in governments, where they're mostly trying to quantify the problems and understand the problems and feed some of their colleagues on the engineering side with information so they can work with. Same thing with engineers. There's consultants are like permafrost engineer in Canada are mostly consultants. There's some in governments, but they're mostly in governments. They're general engineers that work with permafrost. again, most of the engineers in Canada are consultant. There's few engineers in the academic side. Fortunately, that no, we used to be very few a few years ago, but now there's a new generation of professors that are coming in the business, and that's a very, very good thing. The problem is, again, the focus of each one of these groups is different. The interest is different. Each of these groups have limitation, and we have to try to go a little bit beyond our comfort zone. Just give you an example. Typically scientists are very interested in understanding phenomena and observing trends. That's fine, that's very good, that's needed, that's extremely important. But at one point you have to go one step beyond that and say, okay, now what do we do with the problem? Engineers tend to be focused on properties and using those properties as input for design, but they don't make the effort to understand why the properties are so different between borehole 1 and borehole 3. And again, they have to go a little bit beyond their comfort zone and try to understand or join their effort with people that have that kind of knowledge. So there's still lots of barriers in terms of communicating between different groups. And also another important barrier is the role of engineers, who is they have to come up with a design, and they have to take responsibility for that design. And it's something that's not well understood by the scientific community that would like to get involved, but they have to understand that engineers need to control all the information that will go into the design, because they will have to take responsibility for their design. So I guess communication is the key to better cooperation. In an environment like permafrost, it's such a complex environment to work in that there's no way that only a specialized group of people can come up with all the answers. There has to be a group, a wide group of knowledge, a wide group of people combining different type of knowledge to come up with answers. So there's absolutely a need for scientists and engineers to work together better in the future.
Thank you very much, Dr. Dre. That actually perfectly segues into my next question. And sorry, Dr. Dumais, I know you didn't get to answer on that one, but it's hard to pass up on that opportunity for segue. So the next kind of question or discussion topic that we had is actually, what are some of the barriers between permafrost scientists and engineers working together? So Dr. Dre just did a great job in bringing that up. So I don't know if anyone else wants to comment on that and keep it on the discussion of some of the barriers and how we can potentially work on overcoming them together.
I'll start with that one to have the opportunity
Perfect.
to talk. And to add to what Professor Doré was mentioning is the responsibility that you have as an engineer, you understand it the first few times you have to sign something, and that you're responsible for a big design or a small design. So the need to control what you're putting into your design is very important. And so when you put your signature, and it's not only that you're approving the design, but you're responsible for it. You're liable if something goes wrong. You're responsible for it is a big thing. And so but as an engineer, you need to be humble enough to know that you cannot control everything, and you need to reach out to those who knows more than you about it. And so my experience in practice is mostly in Eastern Canada, so mostly in Quebec and Nunavik, where I worked on very small projects. And so sometimes they're low-cost project, low-cost geotechnical investigation, And so these projects tend to be treated by engineers as permafrost is just another condition of soil. So some geotechnical engineers think that they can work on permafrost by not knowing much about permafrost. But it's important also as engineers to be able to understand that you don't know everything about permafrost, and that permafrost scientists might be the people to go to understand why permafrost is the way it is and behaves the way it is, not only from the mechanical, like engineer side of things. And like working in consulting companies, you realize that there are barriers even within the companies between people working in Western Canada on project in Western Canada and people in Eastern Canada. And so it's important to make the next step in reaching out to the good resources wherever they are, and however difficult it might seem to be.
I think one of the things that the science community needs to really appreciate is that engineering is almost always about money. People are spending money on a project. This isn't somebody's grant. It's not some kind of, little bit, $3,000 here or there for a little job that you go and collect some data. This is people are looking to spend hundreds of thousands of dollars on projects. Even a small thing like a bridge costs hundreds of thousands of dollars. If they ever build a bridge over the Yukon River, it will be at Dawson City, it will be millions of dollars. And in the end, as Simon has said, and Guy, there's a liability associated with that. So this is like a real problem. You can lose your livelihood if you do a bad job. And it's been shown that you have done a bad job. In the scientific world, we always write our papers and say, well, maybe, if you consider this, and maybe if you consider that, and we think that it's likely that this is the case, or there's a good chance that that's the case. And so we're more concerned with trying to understand environmental systems and trying to refine what is the best idea. And we're not usually concerned with cost. We might be concerned with how much it costs to go in a helicopter, but we're not concerned with the cost of the final product, which is completely outside our upbringing and training. And for that reason, as Simon said, it's very important to be humble. That's exactly the thing, is that people who are going to use your information as a scientist are going to put their reputation and their livelihood on the line. And we haven't yet had many cases in Canada where people have traced things back to scientists and said, well, what you did was, misleading, and I based my ideas on what you did. And now I'm stuck with, potentially going to jail, right? We haven't got to this stage. But that's because we write in such a way that we never are absolutely categorical. But if you're building a building, you have to be categorical that it's going to stand up. And one of the areas which is really tricky at the moment is, what do we do about the next 50 years? Because you build a building, you expect it to have a service life of, say, 50 years, or a bridge or a road or something. And this is an area in which the advice that we supply regarding climate change becomes very important, because the nature of the foundation is likely to be adjusted over the foundation soils will change over the next 50 years. So this is an area where, for one of the first times, the permafrost scientists are coming directly up against the financial consequences of what they say.
Maybe I can follow up with a question. You really thoroughly talked about the barriers and also the liabilities and the realities of our world. But do you have ideas about how we as a community that we're forming with this short course and also with the RCOP later, how we can close gaps as a community between the permafrost science and cold region engineers?
Very high level, I think that opportunities like this to speak with permafrost engineers and scientists is the first step to actually understand what those complications or those barriers are. And so PYRN has done a great job. Permafrost Net, different programs through Transparent Canada where scientists and engineers can work together, such as, and I won't get into the acronyms, but they're really great opportunities where engineers and permafrost science are being funded to work together on a problem. Maybe so not always with those liabilities, but to actually better understand what the problem may be or may be in the future with respect to, for example, infrastructure. So where that liability is not, I guess, first and foremost. I think as for myself, those are, to me, like the best opportunities where I'm starting to build those connections and cross those bridges with permafrost engineers.
Perhaps I can add a few words here. Again, getting the two communities to work effectively together depends what you're doing. I think if we're just trying to improve the way to do things, way to improve knowledge on permafrost engineering, I think it's essentially communication. So, and the good example of that is our experiences with NTAI, the network of transportation, Transportation Adaptation Initiative, sponsored by Transport Canada, and they created a group of engineers and scientists, get everybody in meetings, discuss different issue, exchange information, presentation. They also sponsor a project where engineers and scientists would work together on those projects. So that's one thing. The other thing is problem solving, and that's probably the most important thing, the most critical. When you're facing a problem, what's the best way to solve the problem? And there, I think we need a lot the leadership by the agency, the owner of infrastructure that need to solve the problem, and they somewhat need to force engineers and scientists to work together to help solve the problem in a technical area that's extremely complex, and there's no way that only scientists or only engineer can solve the problem. And good examples of that, there's example in Quebec where the Quebec Ministry of Transportation, every time they were coming up with a project to adapt an airstrip or a road, because there was some performance issue with those structures, they would hold a meeting with few engineers, few scientists, and brainstorm on the problem, on the context, and on possible solution. And then the engineer would leave with the notes of all the ideas that were produced at the meeting, and they would come up with the preliminary design, and then the group would come again after the design and comment on the design. And something similar is actually happening in the Yukon, where they also have a problem with the stability of an embankment. And they're organizing meetings with scientists, with engineers, and trying to organize, like, again, to brainstorm, discuss the condition, discuss everything that has been observed on the site. What are the possible solutions? Discussion about the solution. And I think that's the way to go. And that takes leadership from agency. Otherwise, agency would simply go through normal contracting procedure. They would follow the rules and hire the best the contractor with the best proposal, and then go ahead with that, without really requiring specific competency or knowledge about permafrost, and that creates problems. So I think that there's a need for agency to change their way to do things, and again force cooperation between scientists and engineers.
I think
great. I think that. No, please go ahead, Chris.
No,
if you have something to add.
Well, all I would say is that at different stages in the life cycle, there are different opportunities. And that means that when you are a student, there is a lot of opportunity for meeting people who work on the same area but with a different perspective. As you start to have employment, you find that you become very, very, very busy. And I don't know in Canada any engineers who work in permafrost who don't say they're busy. This means that there's not very much opportunity for sort of blue skies discussion, except unless, as Guy points out, an agency forces you to do this. And it's unlikely that the private sector will force you to do this because of the liability issues in innovation. It's actually a tricky thing to innovate in engineering because of liability. In some jurisdictions in Europe, for example, I know of stories where innovation in permafrost in Switzerland is not necessarily what is happening because there is a particular way of doing things, and the particular way of doing things, if you do it that way, then you're safe from liability. But in the student environment, in other words, in the educational environment, there is a lot of opportunity for connections to be made. And the important nature of the connection is not the formal connection. It's not that you got a certificate after you attended a meeting or you attended a course. This is not important. What's important is that you now have people that you know, some of whom may be your friends, with whom you can discuss things in the long run, and who, when some other problem comes up, you will say, "Oh, I will talk to them," and you pick up the phone and you discuss with them. So one of the things that, certainly speaking now from the perspective of the IPA, I would say that we're very proud of PYRN because it does that very, very well. That there are many opportunities for people to meet each other and to know each other. And then, as the years go by, that's when, the Zoom call or the email or the other connection becomes, it is really real. And that's where the connections will become stronger because of the opportunity to meet people that educational environments provide.
Yeah, thanks, Chris. I think we all have a little bit this feeling, especially here in PYRN with like the COVID times. It would be nice to do more of this networking, and it's really important, I think, and it's nice to have this at least in such a way here, and I think we all benefit a lot from that. So maybe the next follow-up question, we talk now a lot about how to close the gap, but so the next question would be, what would you really like to learn from the others, like kind of way of working or some specific knowledge, or as well, like where do you think the others might be lacking something that you could offer the others? So more a little bit about the topics like knowledge, way of working, kind of how to approach things. It could be different possibilities.
So it was just mentioned quite a bit with respect to kind of the contracting procedures, when you need geotechnical information, when you actually take into account different scientific perspectives or knowledge, and then how you actually apply that to the problem. So understanding how a bridge is designed or built, and when you actually would want to work with a permafrost scientist, and I think that would be interesting. It's a bit of that entire start to finish project from geotech to design to actually constructing, and then actually kind of looking at how it performs like post construction. That's a bit of a black box, I'd say, to most permafrost scientists that are not engineers or not involved in the applied sense. So figuring out where you actually need to have those discussions and when, and I think would be super valuable information. Yeah.
Judith, one of the things that I think sometimes gets lost in the scientific world is the importance of science for society. There are a lot of people who believe that the importance of science is to create new knowledge, and it doesn't really matter what kind of knowledge that is, how applicable it is, or anything like this. But the vast majority of the reason why science is supported in the Western world is because governments believe that science will lead to better conditions for humans to live. It means that we will increase the reliability of our infrastructure. It will increase the reliability of our medical profession. It will increase the reliability of our ability to effectively control the environment. That's the root cause. That's the root reason why governments support science. If they were just interested in discovery of things, they would reduce that amount. They would reduce their investment because they would just say, if we really need it, the private sector will do it, and it'll all be done by private science. So, in that context, it seems to me that permafrost scientists are in a very privileged position, because you've heard from Simon and you've heard from Guy how our perspective on the behavior of frozen ground is actually of material use to decisions that involve construction of infrastructure. And that's one of the simple ways in which we contribute to society, by providing these sorts of ideas and advice and conversations, and having an element of being able to discuss with people who are going to do something which society is actually going to see rising in front of their eyes. This is something which we can provide some help with, and that is one of the ways in which we are of use to society. And there's a very important distinction between what you might call technical knowledge and what you might call scientific knowledge, where scientific knowledge is essentially designed to delve deeper into the operation of environmental systems. So when most people conduct science, what they're really looking for are new questions. So you do some work, and what questions does that lead to? Whereas the technical knowledge and the technical training that we get is stuff that helps us to actually do things, and it helps us to provide for society structures, in this case, which are more reliable, and which are therefore safer. And this is one of those connections which I think we're very privileged as permafrost scientists to be engaged with, because there are many other scientists who are engaged with things where the connection between science and society is much less direct. I'm thinking about, for example, cosmologists. They may be involved in fundamental understanding of the development of the universe and what happened in a few nanoseconds after the Big Bang, right? But the connection of that to what we how we're going to live our lives on a daily basis in a technical sense is much more difficult to make.
Awesome, thank you very much. So actually, I have a bit of a follow-up question to one of the points you made, Ashley, and kind of about the black box of where we all fit in together. And so one of my kind of questions or thoughts was, in a typical development project, say you're building a road across a permafrost environment, obviously the engineers play a really major role, but is there a specific role that scientists typically play in a project, or is there room for where the engineers can say, hey, I really need a permafrost scientist who can like help me understand how the landscape is going to change in 50 years by doing some sort of like modeling future permafrost conditions? Is that already a thing, or is that kind of where the future should be leading towards? Oh, and also before we answer, if there's anybody in the audience who has a question, feel free to raise your hand or unmute yourself. But yeah, that's my question.
I don't have the answer. I can only assume Simone or you.
Well, I can make a comment, and that is that if you look, and this is a Canadian perspective, of course, in Canada, before we have many projects in northern Canada, both in the Yukon and often in the NWT, there is a requirement for many projects, development projects, to undergo an environmental assessment. And if this is a big project, then it becomes a very public process. That in the Yukon, it's always a public process, but sometimes it's just by exchange of paper rather than a hearing or anything. And in environmental assessments of projects, characteristically, engineers and scientists are both involved. Characteristically, the engineers represent the developer and what is intended to be done and how it is intended to be done. And the scientists pose questions about what this will mean for things like the fish or the nesting birds and so on. Now, and this is the point I think is an important point. I was asked to get involved with a number of projects, but the one I spent the most time with was the Mackenzie Gas project, which is a project that didn't happen in the end. But it was 7 years of environmental assessment, but particularly an intensive period in 2003 to 2006. There were many public hearings. There was a lot of material that had to be reviewed, and there were all sorts of suggestions as to how the project should be adjusted that were coming from both scientists and engineers. At one point, I got quite concerned that I didn't know enough about steel, because the pipeline was going to be made of steel. And what were the properties, not just of steel itself, but also what happens when you have steel in a tube, and what is the stresses and strains that steel in a tube can handle in ways that, and it depends on things like what is the pressure of the material inside the tube, as well as the particular diameter of the tube and the width of the steel and the quality of the steel and all of this. Simon will know all of this very simple, because he learned, I'm sure, learns this in first year. But I'd never learned any of this, so it was actually a tricky thing. So I asked some other people, you know, this is so much a technical problem. Why are you bothering to involve me in this? And their answer was, well, we want you there because you have a lot of field experience. So what they were looking to the scientist for was experience of interpreting the landscape. And when they said interpreting the landscape, they didn't mean, you know, what the Dutch would call the landschap, the big picture, this land vision which doesn't change over human timescales. They were actually thinking about, what is the difference between the conditions in the ground at the bottom of slopes and at the top of slopes? What is the difference between where is the ground moving and where it is not moving? Where would we expect the most hydrological response to climate change to occur? Where was it going to be important? And what they said was that because of the field experience that had been acquired, there were questions that when someone would say, well, what will happen when this project occurs? They could ask somebody who had some idea of how the landscape functioned to say, well, I've never really thought about what a pipeline will do in this area, but now that I'm thinking about it, this is what I would suggest. And that's because I'm familiar with certain elements of the ground ice distribution. I'm familiar with certain elements of the active layer development, familiar with certain areas of snow accumulation. I'm familiar with certain, about the region. And I was very surprised at that answer. And I was particularly surprised because the emphasis now in permafrost science is moving very strongly towards modeling and away from field investigation. And I said to them, well, surely for all of this, you can get a modeler. And they said, well, we could get all sorts of modelers, but they don't know the place where they're modeling. So they can't help us in any particularly specific way. So I would say in the end that one of the things that the scientist can, one of the gaps that the scientist can help to fill is through extensive field experience. And that's not something that is easy to acquire. That takes time, and it means you have to stick at it. But it does seem to be, given what they told me at the time, it does seem to me something that they see that the scientists can provide, but they can only provide it if they stick at the job that they have been, tasked with, which is understanding the landscape.
Yeah, there's definitely lots of room for interpretation, and the importance of field studies and understanding how environments operate and how they're going to change is very important. Guy or Simone, do you have anything to add to that question?
Maybe just to mention that Dr. Rudy mentioned that for scientists, building a bridge or like the design of a bridge might be a black box, but for many engineers, how permafrost was created and why we have that excess ice and the distribution of ice in the ground and how is also a black box to not all engineers, but some engineers, because when you get to do a master's, a PhD, you do some research and you have those opportunities to go to conferences, do courses that are more advanced. But for some engineers with less experience, the knowledge of that permafrost landscape and the properties of the permafrost, they come from science at the basis of it all. Like it's not just an engineering system. It's the understanding of it comes from science. And about the question, when in the project can a scientist come in? There are many steps where like a scientist can come in. It can be at the very beginning to understand, well, like, what are the conditions of the permafrost where we are and what do we have to look for? And then the engineer starts to think about the design as a function of the understanding of the type of permafrost or the conditions of the permafrost that you have at a specific site. And then when it evolves, questions arise, and then you go to the right person to answer those things. But I think, as Dr. Byrne mentioned as well, the experience of being in the field is priceless for like any project, any infrastructure project. And not all engineers have that experience of being in the field. And I would suggest any fellow young scientists or engineers as myself to try to get as much experience as the field as possible, because it's very valuable indeed.
if I can add my grain of salt, I guess all engineering projects in the North are optimization. That means that you're maximizing performance under constraint. Constraint is 99% money. So you have to optimize your work considering a limited budget. The way to do that is to have a very good knowledge of the environment will allow you to adapt your structure to different environments. So perhaps you can, if you're building a road, you can build 10 kilometers of the road with minimum thickness because you know this is an area where there's no risk. And then you're gonna spend lots of money on the next kilometer because you know it's an area where there's very high level of risk. And that knowledge requires a good understanding of the context, good understanding of the mechanism, and good understanding of the effect of climate change. And I don't see that engineers are not alone don't have that knowledge. They have the knowledge on the design, but they don't have the knowledge on the context. So they need to work with scientists with very intimate knowledge of a given area. And as Simon mentioned earlier in the today, he mentioned that we have the engineers have to be humble and know that they don't have all the answers. Unfortunately, engineers they need to sell their competency, and they will claim that they know, probably a little beyond what they really know. So they they have again to be humble and realize that they don't know all the information required to optimize the project. So it's obvious that scientists have to be involved in engineering work in the North.
And you're talking about optimization of the design of the project, but it's also optimization of the site investigation that you're going to do. Because if you have a good understanding of the permafrost landscape where you're working, then you know where to put your money to do more borrows or less borrows, or more of that investigation, less of that. And then you're optimizing the money in the end by reaching out to that knowledge that we have that is less expensive than going and just doing borrows all over the place just because you need borrows all over the place.
But as you know, Simon, one of the great skills that an engineer acquires is the ability to make the right balance between capital cost and maintenance cost. And with climate change, this is a really difficult problem. How do we decide how much we're going to spend at the beginning of a project, which is where the site investigation takes place, and how much we're going to say, well, when there's revenue coming from the project, I can use some of that revenue to maintain my project when things don't go as the performance is expected. And I'm always in awe of the people who have to make those decisions, because it's a very, very tricky decision to make. So there you go.
It's always very tricky to convince someone to spend more money at the beginning of the site investigation to save more money in the long run. But that's the work you need to do as an engineer, and backing up your work with the work of scientists, right?
I just wanted to comment, just this vocabulary of optimization for maximized performance under constraints, that type of vocabulary is not something that I would have been familiar with. And it's become a more familiar conversation within conversations when you're working with these different NTAI groups, but just actually melding that type of vocab between permafrost science and engineers might make actually discussing the problem more understandable for both groups. It makes complete sense how you have to think about maintenance costs and initial costs and where you want to do your site investigations and spend money with respect to permafrost conditions, but that's not something that as a permafrost scientist you would traditionally think about when designing a project. But if we want to design projects that are more conducive to each other's kind of goals, that might be something to think about.
Great. So thanks a lot for these insights. We just want to change the topic now a little bit because we are PYRN and there are a lot of very young researchers here as well with us. And so our question would be, are there any possibilities already for as well students or PhDs to learn from each other, like for example, summer schools? Can you recommend something or shared courses, or would you think this is something that should be done more? And probably I take this together. We got a question from Anna. So what are the burning questions and important topics and challenges young researchers should investigate? So maybe one of you can comment to one of those two questions.
You know what? One of the things that is always interesting is that an engineering project takes place or is going to be developed for a particular location. You know, we don't build bridges that have, you know, wings and are carried around by 747. The bridge is always crossing the river at the same place. So one of the things that the young scientists and engineers need to get a good sense of is the relative balance that they need to acquire between what we call imminent principles. Those are the principles that operate everywhere and are the foundation of engineering design, right? And how we accommodate the specific circumstances of a particular location, a particular bridge crossing, a particular hill slope where a road is going to be built, or a particular particular place. And that is one of the things, that is one of the areas where I have always felt that when Guy and I have shared the course, I've been extremely fortunate to travel with Guy to locations where there have been engineering approaches to the stability of a road. In one case, the Alaska Highway, in that other case, the Inuviatuk Highway. But it's very much concerned with what is happening at this place. Like, we're concerned with individual location behavior because individual locations illustrate how to apply general principles. But in every location, it's slightly different. There are little things that are modified from one place to another. And the idea of somehow being able to accommodate site-specific information within a general intellectual structure is I think, a very important skill that people need to acquire. And the earlier that you begin to acquire it, the better it will be for your career.
Yeah, I have to leave quite shortly, so I will follow up with a suggestion or idea. So when I was a student, I actively sought out opportunities to get involved with different networks or different projects. So I was a part of ADAPT, which was a NSERC-funded project that Guy was a part of at some point, but there was a student organization, and through that I got involved with European researchers, which evolved into a bunch of different networks, which I'm really happy about, are very valuable as an early career scientist. Also being involved in the CPA and PYRN, like these are really great opportunities to just meet these people and to hear about these other opportunities for these short courses. And I would recommend trying to get involved or take part in some of these short courses, particularly when they are cross-disciplinary. Seeing when you're driving along a road and you are stopping with engineers and scientists, you get both aspects, which is invaluable to understanding the problem. So just really search out and take advantage of the different opportunities you have as a student. And as Chris mentioned, you have a bit more, you might not feel like it, but you ultimately have a bit more time to take advantage of those opportunities, which you don't always have when you're starting a career. So do as much as you can now. And then I'm going to head out, but thanks again. And thanks for the great questions. It was really great to be part of this panel. So I appreciate it.
Thank you very much, Ashley.
Thank you, Ashley.
Bye.
Maybe just to kind of round up now, because we're almost up to an hour. Maybe we can do this as a round of all panelists. We were interested in what are you as scientists and cold region engineers, what do you expect from the RCOP? What would be your wishes? And do you plan to attend any specific sessions from the other panelists maybe? Yeah, maybe everybody can shortly comment on that.
Well, I can perhaps start. I think that what I would wish that happens, and that of course the young engineers and the young scientists are the one that will help build bridge the gap. And the gap is actually, we have to realize that there's a huge gap between the state of the art and the state of knowledge. Engineers live and die by the state of the art. They refer to the state of the art. Everything they do is based on the state of the art. The state of knowledge is typically way ahead of the state of the art. And any progress that's made by scientists, there should be an effort to bring that new knowledge into a guide, into a standard, into a document that makes it available for people that, again, live and die based on the state of the art. So very important to again, do the extra effort when there's a new knowledge, to take that knowledge and build it into a specification, a guideline, something so people can refer to that information. So I think it's something that should all young scientists and young engineers should keep in mind to their career.
I would also say, in conferences like that, be curious. Go to sessions that might not be your preferred topics. Like I had a prof at Laval that told us, like, your eureka moments, they come sometimes from when you're listening to a talk that has nothing to do with what you're studying, because your brain's making connection and so on and so forth. And it's a nice thing with RCOP that the presentation are recorded, because you'll get to watch all of them when you have the free time. You won't have conflicting moments when you want to be in 3 sessions at the same time. But as Ashley mentioned, be involved in organization is the best way to make connection and learn about all these things.
I agree.
Well, I think with that we can wrap up the PYRN, CPA, USPA, and IPA Permafrost Science and Engineering short course. We're just a little bit past the hour, but I think we've had really good discussion. We've had a lot of good questions from the audience, and we've had a lot of great discussion. So I think there's definitely lots for all of us to think about and look forward to in the future. So I know that Dr. Ruy has already left, but I would like to thank all 3 of you very, very much for being panelists today and also providing lectures over the past few weeks. I know myself as someone who has a background in permafrost science, I've learned a lot of really valuable information that I'll be taking forward with me in my career for sure. So with that, I would like to thank you all and adjourn the short course. And thank you to all of the attendees for coming today and over the past few weeks. And hopefully we'll see many of you at the RCOP conference at the end of the month.
Thank you very much for making this possible. Excellent.
I know, Adam, how much it takes to organize one of these things. There's a lot of work. And you have to be very flexible because things happen that you don't expect. And I think it's very easy when something appears to be seamless, you don't know, most people don't know what goes on. And I think we all appreciate the effort that you and the committee have made, all of the committee have made for this. There hasn't been anything quite like it before. And so I think we all are very grateful to you for the efforts that you've made, and are very, very happy that it's been successful.
Well, thank you very much. I couldn't have done it without Judita and Charlotte and the rest of the PYRN committee.
Yeah.
All right. Well, it was nice to see everyone, and we'll see you in the future. Bye, everyone.
Bye.